in this video, we're going to be doing Calc AB problem set number 102. The problems and the playlist are in the description below. Let's see what we're doing. All right, use the table of values for the differentiable function. So differentiable implies continuous to answer the questions. Approximate f prime of 12. We've done this, I don't know, it feels like 100 times at this point. F prime of 12 approximately. So you got to do that or you're going to lose a point. We're just going to find 12 in the table. It's going to be between 10 and 14. So we're going to do the slope of the secant line between 14 and 10. So f of 14 minus f of 10 over 14 minus 10. That's going to be 8 minus 6, which is 2, over 14 minus 10, which is 4. So we get 1/2 as our answer. And that's part A. So you can kind of blow through that at this point, hopefully. Prove that f of x equals 5 for some x. So we have a table of values for f of x, and we want to prove something about f of x. This is almost certainly intermediate value theorem. If it was about f prime, it would almost certainly be mean value theorem. So in this case, I'm thinking I of et. So I just need to find a place where I'm above 5 and then below 5. And if you look kind of on this interval from 22 to 25, we go from 11 to 4. So somewhere in there you must equal 5, but we got to set it up, right? So I'm going to say that f of x is differentiable, which implies continuous. And again, like if you've done all the problem sets, you've done this type of problem a lot, you get very comfortable with it. And then on the AP exam, you just like crush it. All right, so f of 25 is the smaller one. So I'm going to go f of 25 is less than 5, which is less than f of 22. And then so by intermediate value theorem, f of x is equal to 5 for some x between 22 and 25. And that's all you need, right? So each of those three parts is essential, but that's the answer to the question. Let's take a look at the next one. Approximate the average value. So average value is integral divided by interval on the interval from 10 to 25. And then we're going to use a left sum to do it. So first, we will write down integral and then divide by the interval, which is between 25 and 10. So 25 minus 10. Approximately, because we're not getting the exact value. So don't forget to write the 1 over, so 25 minus 10 is 15. So 1 over 15. Most common mistake that I see people make is they just forget to write that part. Now we're going to use a left sum on the integral. So we go from 10 to 14, which is 4, and then the left endpoint is 6. We go from 14 to 17, which is 3, and the left endpoint is 8. We go from 17 to 22, which is 5, and then the left endpoint is 13. And then we go from 22 to 25, which is 3, and then the left endpoint is 11. All right, and then you could leave this on the AP exam, and I highly recommend that. But if you're like me and you don't like doing that, I ended up with 146 over 15, so let me know if that's wrong. I don't think it is. Next up, given that g of x is the integral from 4 to 2x of f of t dt, we want to find g prime of 7, so we're going to need g prime of x. That's going to require the second fundamental theorem. So we take the upper bound and plug it in. So that's going to give us f of 2x times the derivative of the upper bound, which is just 2. That's it. And now g prime of 7 is going to be f of 2 times 7, so f of 14 times 2. F of 14 in the table is 8. So we get 8 times 2. So overall, we're getting 16 as our answer. All right, let's take a look at the next one. So a little warning on this next one. This, I believe, is actually harder than any one problem that you would see on the AP exam, but you might see 2 different problems that are contained within this problem. So I'm going to do it. You should be able to do it too, because you definitely know how to do it. But keep that in mind. So you see something like this, your initial instinct is it's probably a u substitution problem where u is the denominator. But then when you try to find du, you get 2x plus 4 dx, and we don't have that. We have x minus 2. And so there are things we could do, like clever things, but we don't really want to be clever in this case. So what I'm going to do instead is I'm going to say that this method isn't really working for me. And I'm going to think, what else would I do? So if there's a quadratic in the denominator, one thing I would try is I would complete the square in the denominator. So I'm going to show beginnings of that. So I realize that it should be x squared plus 4x plus 4. That's a perfect square trinomial. So I need that plus 4, and I already have plus 29, so I just broke that into 4 and 25. If you've watched me solve a lot of these, you'll notice that I do that a ton, because almost every AP question is set up that you can just do that. Completing the square is, however, a very useful skill to bring into this. All right, so then I would rewrite this thing with the square completed, right? So x plus 2 quantity squared instead of x squared plus 4x plus 4. Now what I'm going to do is I'm going to let u equal x plus 2, the thing that I just got by completing the square. And like, you're not going to run into this problem, but if you do run into this type of problem specifically, you always can follow this method. It will always give you the solution. If u is equal to x plus 2, then x is equal to u minus 2, which means that du is dx. We could have gotten that from the first step, but we actually need to replace x in this case, so I needed that step in the middle. So now I'm going to replace x with u minus 2, and then there's another minus 2. And then I'm going to rearrange the denominator so that it looks like kind of like arctan, 25 plus u squared. And so this is u minus 4 over 25 plus u squared. I'm going to break this into two separate integrals that I'm going to deal with. And when I break it up, I'm going to break it up in such a way that, I don't know, 7 out of 10 times I will get the final answer wrong because I'll forget that minus sign in between the integrals. I do it to myself all the time, and you would think I would learn not to, but I don't. So I'm going to handle each of these separately, and I need a whole other slide to do it because we're out of room here. So here goes. All right, so don't forget that minus sign. I'm saying that because when I originally wrote it, I did forget the minus sign, and I had to go back and edit it. All right, so for the first integral, I'm going to make w, because there's already u's in it, so I'm going to make w 25 plus u squared, which means that 1/2 dw is u du. And now we can perfectly substitute, so we get 1/2 dw over w. That's definitely a natural log. 1/2 natural log absolute value of w. Natural log absolute value of w plus c. And then w is 25 plus u squared. And if you remember, 25 plus u squared is the original denominator that we had. So 25 plus u squared is actually the original denominator, which was x squared plus 4x plus 29. All right, so that's one of our integrals. And that is definitely an integral you would have to do on its own, like no question. The next one is also definitely an integral you would have to do on its own. It's that like step where we got to these two integrals. I don't think they would put on an AP exam because it doesn't really test if you like are competent with calculus, which is what the exam is testing. So I've taken out 4 here. I got 1 over 25 plus u squared. This is, to me, clearly an arctan. I've got to take that 25 out of the denominator. So 4 over 25, that'll give me 1 over 1 plus, and then it's u squared over 25, but I'm going to make it u over 5 squared because in my head I'm already thinking this is arctan, so it should be 1 over 1 plus thing squared. So there should be a 1/5 in the numerator, which means there should be a 5 on the outside of this thing to balance that out. So 5 times 4 over 25 is 4 over 5. And then this is a perfect arctan, so it's the arctan of u over 5. U, so now you got to remember what u was. U a long time ago was x plus 2. It's from when we completed the square. You should, if you're doing this, you would have the work in front of you, and that's easier to remember. So this will give us this. And then finally, we have to combine them, right? So we're supposed to do our first answer minus our second answer, which is what I forgot when I wrote it out the first time. So it's 1/2 natural log absolute value of x squared plus 4x plus 29 minus 4/5 arctan of x plus 2 over 5 plus c. So I've said it multiple times. I think overall this problem is too hard, but I do think individually both of those integrals are definitely on the level. Probably on the level of like, I don't know, they're not... The second one, the green one, is a little more challenging because arctan is kind of inherently more challenging. The first one, the one that we ended up doing in white, is like a totally normal natural log integral. So anyway, that's the problem set. Hope you found this helpful, and good luck.